Hello everyone, today's lesson is all about the geology of the UK and it covers specification points from the Edexcel syllabus 4.1a and 4.1b. Now don't let that word geology put you off. Geology is a part of geography, but it simply means study of rocks, but moreover and more deeply the processes that have shaped the earth. So by the end of today's lesson, you should be able to explain why different parts of the UK have different landscapes and different rock types. You'll also see that the geology links to many things that my students may already have done with me when it comes to uplands and lowlands. If you have a guided notes booklet, please use that. That will be very useful for you to review later on. If you don't, this lesson is good for anybody that's reviewing or studying GCSE Geography. This icon will appear on the slide when you should complete something in the guided notes workbook. But as I said, not crucial if you don't have it. That's okay. You may want to take your own notes. And of course, you can pause the video in your own time anyway. So let's begin with a short retrieval task. So I'd like you to think about everything you studied so far. Think about the process that has shaped the UK's landscape and write down as many as you can remember. Put them into two groups: past processes and processes acting today. Okay, let's see what you've come up with. So you've separated them to past in plate tectonics, folding, anticlines, which we've studied, and synclines, and also glaciation from the last ice age. So these happened millions of years ago, in some cases with glaciation hundreds of thousands of years ago. So these are the foundations of today's landscape. Then we have the processes that are acting today, so things that are current today. They're present, especially on the surface. These processes of weathering, rivers shaping and eroding the landscape, and also mass movement and slope processes. So these are the processes that continue to change the landscape. So today's lesson is mainly about the first group. And we're going to go back in time, really, to understand why the UK looks the way it does today. Let's check our understanding. There's something in your guided notes. If not, worth writing down. See if you can recall some of the information from here. Words are on the bottom to help you. So, glaciation has created rugged, steep landscapes in our upland areas. The folding created structures such as anticline, domes are in the Weald. That's an area where Edexcel is, where we visited. And the different rock types vary in resistance. So, fairly easy start. Okay, on your guided notes, again, there are three major rock types that make up the UK's landscape, and this lesson really centers around these three. So, sedimentary, igneous, and metamorphic. So in the next 30-40 minutes, you will know how each rock forms, how it affects the UK's landscape. You don't have to memorize everything, and there'll be points where you'll see an icon where you can actually pause and fill in your guided notes or make some notes. So this is, like everything in geography, it's base foundation for which will build over time. So take a careful look at this map, courtesy of the BBC and BBC Bite Size website. So before I tell you anything else, I'd like you to look for patterns. Where are the sedimentary rocks? Where are the igneous rocks? And where are the metamorphic rocks? Now, obviously at this point I haven't put the key on, but if you studied uplands and lowland lessons with me, that should be pretty easy and basic. Okay. So hopefully you noticed something interesting. Most of England, so the south and east, is made up of sedimentary rocks, whereas the igneous and metamorphic rocks, they are much more common in Scotland, Wales, Northern Ireland, and parts of northern and southwest England. So keep this pattern in mind because it explains why the UK's landscapes are so different. Okay, you've got this table in your guide and notes, and you're going to tick it off once you've found out. Okay, let's begin with our sedimentary rocks. That word sediment should give you a clue. So imagine there are tiny pieces of sand, mud, pebbles, even the shells of sea creatures, and over millions of years, these layers build up. So the enormous weight of the layers above then compresses everything, and eventually they become rock. So sedimentary rocks are often formed in layers. So in the UK, we find chalk, clay, Carboniferous limestone. So these rocks formed in ancient seas, rivers, swamps, hundreds of millions of years ago. You may want to pause the video now and refer to your table. So, although all these sedimentary rocks, these are all sedimentary rocks, they do behave differently. Chalk is softer than limestone, but harder than clay. And because chalk is permeable, rainwater can soak through it. That's why chalk landscapes, they often have contain dry valleys and springs. Clay is different. Clay is impermeable, so water can't pass through it that easily. Instead, it flows across the surface, and that's why clay often forms much flatter landscapes with lots of rivers and streams, and Carboniferous limestone is obviously much harder. So this means it can create dramatic limestone sceneries like caves and underground rivers, many of which you've seen in other previous lessons. So let's take a little closer look at limestone. So limestone is made mainly from the remains of tiny marine organisms that lived in warm tropical seas hundreds of millions of years ago. It's hard rock, but it also has joints and cracks. Rainwater is naturally slightly acidic, so over thousands of years that acidic water slowly dissolves the limestone, and this is a process called carbonation weathering. There's another lesson on weathering when we talk about that. So create some spectacular landforms, caves, caverns, dry valleys. And later in the lesson, you'll see a good example of that. Malham Cove, which we'll have a look at in the last couple of slides. Okay, so before we move on to our next rock type, let's look quickly at where sedimentary rocks are found in the UK. So, notice the pattern. Got Carboniferous limestone. This is in places such as the Pennines. Chalk. This dominates much of southern England, including the famous White Cliffs of Dover. We've got clay and sandstone, which is widespread across the southeast. And this is really important because it means different parts of Britain have different foundations, and these different foundations create different landscapes. That's really the main idea that we're going to keep coming back to throughout today's lesson. So here we have the famous White Cliffs of Dover, where chalk dominates. Okay, let's move on to our second rock type. This is igneous rocks. Now, the word igneous comes from the Latin word for fire, so that should straight away tell you something. These rocks begin life as magma or molten rock. So when this magma cools, it becomes solid. If it cools underground very slowly, then large crystals have time to grow. Rocks such as granite form in this way. If lava cools at the Earth's surface, much smaller crystals form. And this is how basalt is formed. So one thing you really need to remember for exams is that igneous rocks are generally very hard and very resistant to erosion. And this is why they often form some of the UK's highest upland areas. So here's some classic examples. Dartmoor, Giant's Causeway, Scotland, Lake District. So they all have that one thing in common. They're dominated by hard igneous rock. So we're going to see a pattern, aren't we? Hard rocks usually means higher land, steeper slopes, more rugged scenery. It is the geology that's controlling the landscape. So here's Dartmoor. If you've ever visited Dartmoor, you'll probably remember there's huge open moorland, rocky hilltops, massive granite tors. So none of this is accidental. This is the granite underneath, which is extremely resistant. So over millions of years, that softer rock surrounding it has disappeared and the granite has remained. So what does Dartmoor look like? Well, that answer starts with granite. Now we move across to Northern Ireland and one of the most famous geological sites probably anywhere in Europe. This is the Giant's Causeway. So according to legend, these columns were built by a giant called Finn McCool. It's a brilliant story. If I've taught you in year 7, you've heard it all before. But the real explanation is really more impressive, I think. It begins around 60 million years ago, and this lava is spread out across the landscape. As it's cooled, it shrank. That shrinking has caused the cracks to form, and those cracks have created the famous six-sided basalt columns that you can see here today. It's one of the finest examples, I think, of igneous geology. Well, Scotland provides another excellent example. Much of the highlands are made from very old igneous and metamorphic rocks. These rocks, they survive hundreds of millions of years of weathering and erosion. And it's one reason why Scotland has, or contains, many of Britain's highest mountains. Ben Nevis, for example, sits within this geological landscape. Okay, finally, we reach our third rock type. This is metamorphic rock. So the word metamorphic means changed. So these rocks begin life as another type of rock, deep underground. So they experience enormous heat and pressure. Instead of melting, they change. Their minerals are rearranged. They become harder, denser, much more resistant. Some examples of that: slate, schist, marble. If you look at your table, that's where you need to fill that in now as examples. So our metamorphic rocks, formed when heat and pressure cause other rocks to change. And these rocks are harder and become more compact. Shell becomes slate when exposed to heat and pressure, and slate becomes schist when exposed to more heat and pressure. So slate is a particularly useful rock. It's hard, but it naturally splits into thin, flat sheets. So I'm sure everyone's seen that. This is why slate has been used for roofing houses for hundreds of years. North Wales became famous for its slate quarries. Schist is slightly different. It contains larger crystals and also split into layers, but both these rocks are resistant to erosion. So once again, they are commonly found in the upland landscapes. So you've started to notice the themes. Hard rocks usually survive, softer rocks wear away. I'd like you to have a look at these photographs of these land formations that we had a look at a minute ago. Pause the video. I want you to think about what they have in common. So the answer is simple. It's the underlying geology that determines the landscape. So every one of these places looks the way it does because of the rocks beneath our feet. So this is probably the single most important sentence in today's lesson, really. If you remember only one thing from today, remember that. Geology underneath influences the relief, the steepness, the soil, the drainage, and ultimately what's above it, so the landscape above it. Okay, if you have a sheet like this with you, this will be very useful for you to have. If not, you can make notes as we go along. In some cases, you're going to be filling in the gaps, and in some cases, you're going to be adding some arrows in and around this fantastic diagram. Okay, so a recap on these upland and lowland areas. We're going to put everything together here. So geographers often use something called the Exe Line. So it's not a real physical feature, it's an imaginary line running from the River Tees in the northeast of England to the River Exe in the southwest. You can see it here on the right hand side. Why is it useful? Well, it's useful because it divides Britain into two landscape regions. So we've got the north and the west. That's mainly the upland areas. So look north and west. Look south and east. You'll see there mainly lowland landscapes. So just pause the video for a moment and look carefully at the map. Right, before we continue any further, I'm going to show you a short BBC bite-sized video, just over 2 minutes. So as you watch this, think about the examples that you can spot where geology influences the landscape.
The physical landscape of the UK is varied and includes upland and lowland areas. We can see the relief or the shape of the land on this map. Brown indicates high ground and green indicates lowland. In the north and west of the UK we find most of the uplands, Scotland's Cairngorms and the Pennines in northern England for example. Meanwhile the south and east have mostly lowlands, such as the Fens in Norfolk. Let's look at the Peak District, where we can see both uplands and lowlands close to each other. Here we have areas of high ground, ridges and peaks, which experience cool temperatures, high rainfall and strong winds. The lowland valley is sheltered from wind by the higher ground. Here we can see rivers, lakes and wetland areas and greater biodiversity. So let's consider what caused the uplands and lowlands to form. The UK's northwest has more resistant geology, formed from igneous and metamorphic rocks, for example granite and gneiss. These rocks are not easily eroded. The south and the east of the UK are mostly formed from sedimentary rocks like sandstone and clay, which are more easily eroded. Glaciers also play a role in the geology and shaping of the UK. The UK has experienced many periods of glaciation. Here we can see how far ice spread during the last ice age, around 25,000 years ago. These glaciers melted and the meltwater flowed to the south. The uplands were shaped by glaciers forming pyramidal peaks and mountain ridges or arêtes. As ice moved downhill, it eroded, carving through the land to form U-shaped valleys and corries. How would you describe the physical landscape where you live?
So let's look more closely at these upland areas. So most of Britain's upland areas are found in Scotland, Lake District, Snowdonia, the Pennines, and they all have several things in common: high relief, steep slopes, thin soils, cooler temperatures, and a greater amount of rainfall. So these conditions, they make crop farming very difficult. That's why sheep farming is so common. Tourism in these areas is also extremely important. Millions of people visit these landscapes every year to walk, climb, enjoy the scenery. Now let's compare that with the lowlands. So most lowland landscapes are found in south and eastern England. Here the land is much flatter. The soils are generally deeper, more fertile. This makes arable farming in particular much easier. There are large fields, there is better transport, larger towns and cities. This is all really because the landscape is a lot gentler. So this is one of my favourite questions. And the glaciers, as we know, disappeared from Britain around thousands of years ago. So, why haven't the uplands become flat? Why haven't lowlands suddenly become mountainous? Pause the video and see if you can explain that. The answer is that landscapes never stop changing. The glaciers, yes, have gone, but weathering, of course, continues, rivers continue, slope processes continue, so they all work on these landscapes left behind by geology and glaciation. So remember something we've said before, geology built the landscape. Modern processes continue to shape it, and that's a really important distinction for GCSE geography. And here's a fascinating piece of evidence. This is the skeleton of a hippopotamus discovered near Leeds. Now, of course, we certainly don't have hippos wandering around Yorkshire today, but what does that tell us? It tells us that Britain's climate hasn't always been the same. So around 120,000 years ago, this is during a warmer interglacial period, Britain was much, much warmer than it is today. Animals such as hippos could survive here. And later, during the Ice Age, the glaciers transformed much of the landscape. So it's an interesting, funny and wonderful reminder that climates, landscapes can dramatically change over long geological periods. So let's bring today's lesson together. So the UK's geology has been shaped over millions of years, and there are several major processes. We have tectonic activity, which forms mountains and volcanic rocks. We have sediment built up in ancient seas. We have changes in sea levels as they rise and fall. We have climate changes repeatedly. And we have this more up-to-date process of weathering and erosion. So let's now finish with one of Britain's most spectacular landscapes. This is Malham Cove. So everything we've learned today has come together here. This rock is Carboniferous limestone. This is limestone that's formed over 330 million years ago beneath a warm tropical sea. And then much later, during the last ice age, the glaciers have carved and steepened the landscape. And finally, as weathering and water have continued to shape the limestone after the ice has melted. That's it. Thanks for listening.